Welcome to Maths and Science by IITian channel. In this lecture, I will be talking about a physics chapter for NEET, JEE and CBSE for class 11 and class 12. In addition to that, it can even cater to CSIR physics syllabus also. I will be taking up work, energy and power. Lecture number 1. It's an introductory lecture on work, energy and power. With an understanding that you already know the definitions of acceleration and also force and Newton's law. If you are not aware also, we will briefly introduce the concepts of acceleration, force, work and energy in this class or in this lecture. It's an introductory lecture. In this I have given 3 equations in this slide. If you see these 3 equations, little bit of mathematics understanding is also required for better understanding of the physics as far as work, energy and power is concerned, or in overall sense, mathematical physics is also a part of studying physics. For example, you should know about what are vectors and what are scalars. I have discussed at length in my previous lectures on vectors. You please see them, what is a vector and what is a scalar. You know acceleration, A is an acceleration, it's a vector. This vector is a function of x. X is nothing but x vector is position vector. X bar is position vector. I will just define what is position vector. V bar is velocity vector and t is time. Acceleration is a function of position vector, velocity vector and time. And let's go to the second equation. Why I have written them, what are its meanings, we will be explaining the following discussions. You please try to understand the fundamentals and concepts first. Then we go to the theory, then we go to solving the problems. As per Newton's law, what is the force? Newton's law of motion says rate of change of momentum is force. Vector F, force is a vector, is dp by dt. dp by dt is rate of change of momentum. Rate of change of momentum. and here P is the momentum. P is a vector. That is equal to, what is dP by dt? P is product of mass into velocity. Vector P is equal to mass into vector V. That means dP by dt is equal to d by dt of mv. When m is equal to constant, if it is not varying, then m I can take it out. d by dt of v, that is equal to m into a. This is what is given here. Force is equal to ma. How we have arrived at it? This is the way how we have arrived at it. In Newton's laws, force is not directly defined as the mass into acceleration. It is defined as mass times the, or rate of change of momentum, it is defined as. Momentum is mv. Then A and F, these are all vectors. Now there is a scalar quantity called as work. What is meant by work? What work causes? Work causes the motion. Motion means change of velocity. That means change of kinetic energy. Wnet causes change of kinetic energy. Kinetic energy is written usually by T. You can even write it as Ke. That's up to you. And work is causing motion. Motion is causing displacement. Force into displacement, the dot product, the scalar product of force and displacement is work. That is causing change in kinetic energy. That means F.dS, this is the dot product, scalar product. Displacement is a vector, force is a vector, dot product F dot delta S is equal to Wnet. That is work done. When some work is done, what happens to the particle? That particle gains or loses kinetic energy. That is delta T. Gains or loses kinetic energy. This is the concept behind work, energy and power. We will move further. Now, let us try to understand what is position vector in the first equation. A, vector A, acceleration is the function of position vector x, velocity vector v and time. This is Newton's equation. In Newtonian mechanics, we regularly use this equation. because we can even say for an inertial frame, such as Earth, please try to understand the concepts here, very important. Once you understand these concepts, you can apply very well in the physics. Inertial frame means like Earth. Even though Earth is not an inertial frame, absolute inertial frame, we can treat it as an inertial frame for practical purposes, for studying the Newtonian mechanics and also for our regular mechanics studies. T can be neglected. This can be neglected, or this is not required because velocity itself is rate of change of position vector. What is velocity? Velocity is rate of change of position vector. Rate of change of position vector. That means for an inertial frame, acceleration is defined as a function of positional vector and rate of change of positional vector, or it can be a function of positional vector and rate of change of positional vector. This is positional vector and this is velocity vector. Acceleration we have defined as the positional vector, function of. Now, what is positional vector? Positional vector, let us say, there is an xy coordinate system. In that, I put one point P here with x and y as coordinates. This is origin. In physics, everything we should have some reference. For that only, I made an inertial frame as a reference. In this x and y axis, origin as the coordinator. Then P is the point, a position in the xy coordinate system. It is an xy coordinate system. And OP is the positional vector. OP is the positional vector. Similarly, on xy plane, instead of position, I have taken x coordinate and y coordinate as the rate of change of position. Then that will be velocity vector. For example, I need not take x and y as the same distance. Forget it, it is physics. X can be, it is a velocity vector. Here it is a position vector. And I have taken a point P here. What will be its coordinates? Coordinates will be x bar, v bar. That means x and y, as we have taken in our elementary classes, that x as the distance and y as the distance, we take them as only units. That unit can be a position vector, that unit can be a velocity vector. This is velocity vector. I have taken on y axis and it is position vector on x-axis. And what will be the area of this? Area is equal to this area x bar into v bar. That is the area. Like this, position vector and velocity vector, as we have got in Newtonian mechanics, A is equal to function of xvt, and when a reference frame is fixed, we put it as function of x and v. This is the acceleration. This is the acceleration. Now, we understood what is the acceleration. Acceleration is the rate of change of momentum. This is written as acceleration, rate of change of momentum, that is d by dt of mv. When m is constant, it will be dv by dt. This is, sorry, it is not acceleration, it is force. This implies force is equal to m into a, that is equal to dp by dt. This is the equation for force. Now, when force is applied, what happens? There will be change in the momentum. Rate of change in the momentum directly indicates force. That means momentum is involving velocity. That means position is changed. Position is changed. Momentum is changed when a force is applied. Then, when position changes, please try to understand this concept very carefully. Here comes the main work, energy and power. Till now we have only briefed about Newton's laws of motion. Now, positional vector P, and after some time the positional vector P is changed to P dash. This is xy position, this is x dash, y dash, and pp dash is the displacement. From P to P dash, there is a displacement, delta U. There is a displacement of the particle from the position xy to x dash y dash over some point of time. That means time factor is also required to understand the state of the particle. For state of the particle, can be understood by knowing position vector and change of position vector with time. Please try to understand, this is very important. Position vector with time. For example, if I say a particle is there at point P whose position vector I have given, it doesn't give you any idea after a point of time t where that position vector will be, until and unless I give the second position vector or rate of change of position vector to you. That means rate of change of position vector and position vector, these are the two things. That means position vector and rate of change of position vector. These two are the things which are required to understand the state of a particular particle. How you can know without knowing the rate of change of positional vector? How you know that P is moved to P dash in that particular direction? Because rate of change of positional vector is also a vector and positional vector is also a vector. Both have direction. So that we can understand at a particular point of time P is moved to P dash. And we can define P and P dash from this knowledge. And once we know that P and P dash, we can understand what is the displacement taken place. Change in displacement. Change in displacement. That means x position vector, dx bar by dt rate of change of positional vector, velocity vector, delta s change in displacement vector. These are all interrelated. Please try to understand. These are all connected to force in one or the other way. Then what are their connections to force? When you apply some force or withdraw some force under which the particle was also subjected to, under these both the conditions, there will be a displacement, change in positional vector. There will be a rate of change of positional vector, and we can even say even delta p, momentum of the particle. Now you understood the concept behind what is the positional vector and why rate of change of positional vector has to be studied. And when you study the rate of change of positional vector, how it is going to affect the velocity vector and how it is going to affect the momentum. That means for understanding the state of a particle, ultimately what is required in mathematics or physics or engineering or medicine, what we require, we want to know at a particular point of time how this particular particle is moving. A particle is at a particular point of time, it is here, and at a particular point of time it is here, at A and at B. Where it is there at B? Initial conditions we will able to know what is at A, but how to know where it is at B? That means if you know any two things connected to position vector, rate of change of position vector, we will be able to know the position of B. That means you should know x bar dx bar by dt. This is one. Another also we can say x bar v bar. We can even say x bar, because position vector is compulsorily required, and dp. From this we can know displacement. This A to B is the displacement. This displacement is caused by the changes in the position vector or velocity vector or position vector or rate of change of position vector or position vector or momentum vector. Instead of dp we can say p, momentum vector. That means at A and B either I should require this, either I should require this, whatever you call it, require this. Position vector and momentum vector, position vector and velocity vector, position vector and rate of change of velocity vector. Once I know these things, I will be able to know the new position of the particle. Then, for causing these changes, for a particle to move from A to B, what we require? External force. For particle from A to B, we require external force. That means when we apply the external force, there will be positional displacement. And how much displacement will be taken place? It depends upon how much force you apply and what is the mass of the particle. Then the relation between force and displacement, another quantity is defined in physics. The product of force into displacement is equal to called as W, that is equal to work. Work is equal to force into displacement. It is a dot product, it is a scalar unit. Ultimately, we arrived at a conclusion that when you do some work on a particle, it makes a particle to have a displacement, and the work done causes motion in the particle. Motion in the particle means there is a change in the velocity. Another term I am bringing in, change in velocity. Because we have already discussed that x bar and p bar, that means positional vector and momentum vector, can also define the state of a particle. Here I am bringing the velocity vector into picture. Change in velocity vector into something, some constant. Change in displacement is caused by change in velocity. Change in velocity causes what? Velocity causes kinetic energy. Change in kinetic energy, that is delta T. That means work causes change in kinetic energy. Are you able to understand? We have defined a system in an inertial frame. From there, we have arrived at the conclusion that at least two parameters are required for defining the state of a particle, that is position vector and velocity vector, or a momentum vector, or a rate of change of position vector. That is a factor of time. Once we know position vector, velocity vector, or rate of change of position vector, or momentum vector, we will be able to understand the state of the particular particle at different times. In that, at a particular point of time t1, it is at A, that particle, in the coordinate system, and it moved to point B after some time at a time t2. Then, whatever the displacement has taken place from A to B, change in position vector, displacement delta S, is related to the force applied in such a way that the dot product of force applied and the change in position vector gives rise to work. F dash, F bar, that is force, is directly connected to velocity or rate of change of position vector, because as per Newtonian mechanics, force is equal to rate of change of momentum, that is dp by dt, whereas momentum is the product of mass into velocity. Hence, the rate of change of displacement is directly connected to velocity, that is force is directly connected to velocity, and in form of work, we will be able to know that once the given force is given, applied force is given and change in displacement is given, with the scalar product of force and change in displacement, we can find out the work done on that particular particle. Then, what happened when work is done on a particle? There is a motion, there is a velocity change. That velocity change, that can be a gain of velocity or loss of velocity. Velocity is directly connected to kinetic energy, another term we have introduced here. That means work causes change in kinetic energy. That is the from the basics of one-dimensional motion, V square minus U square is equal to 2AS. We will use this concept and present a solution for finding the kinetic energy. We have defined work. From there we will try to define the kinetic energy. Because work causes change in kinetic energy. What is kinetic energy? V square minus U square is equal to 2AS. Can we write like this? V square minus U square is equal to 2A into WS. A dot WS. Where WS is the change in the position. S is nothing but distance between A and B. Where we have defined here A and B. Distance between A and B. Then, can we say WS is equal to 1 by 2A into V square minus U square? That is equal to 1 by 2 into 1 by A into V square minus U square. These are all vectors. That implies, what is work? Work done net is equal to F dot delta S. That is equal to MA dot delta S. A we know, we don't know MA dot into what is delta S? 1 by 2A V square minus U square. That implies W net is equal to A gets cancelled, half M delta V square. It's a scalar quantity, hence we can remove this here. It's a scalar quantity. Because F dot S is scalar quantity. Here we can remove this. For B, we can remove this and this, they get cancelled. This is nothing but delta T, that is delta kinetic energy. This implies the work causes change in kinetic energy. We have started from the position vector, rate of change of position vector, defining the state of a particle in the coordinate system. Once the particle position or state is defined, from there we got the displacement, and by multiplying the displacement with force, we got the work done on the particle. Once work is done on the particle, what are the physical changes it is going to make? The physical changes it is going to make are change in the kinetic energy. That's what we have proved here. Work causes changes in the kinetic energy. Now, we understood what is work, we understood what is kinetic energy. Now, what is power? Power is equal to rate of change of energy, that is dt by dt, rate of change of kinetic energy. This is power. I am here only giving the glimpse what is work, power and energy. Simple definitions, that's all. We are not doing anything. We will be understanding as we go further and further, try to solve many problems, and this is as per Newtonian mechanics. We will move from Newtonian to Lagrangian, which is a simplified method where vector forces are not involved. In the Newtonian mechanics, what are the definitions we have? One is to know the state of a particle, we are required to know, it is in a mechanics, any mechanics, whether it is Lagrangian, Hamiltonian or Newtonian. To know the state of a particle, we are required to know positional vector and velocity vector, or rate of change of positional vector. Rate of change of positional vector, or its related values like positional vector and momentum vector. Otherwise, positional vector and momentum vector. Once we know them, we can know the delta S. From there, delta S by delta T we will know. From there, we can know dP by dt or we can know dV by dt. Little bit of calculus, please try to observe it. We know all these items, all these values. dP by dt, dV by dt, acceleration, we will come to know. Once we know this, velocity vector, once we know this, we apply to the Newtonian mechanics. F external is equal to ma acceleration. And from there we got the definition Wnet is equal to F dot delta S, because F we know, F dot delta S, that is a scalar quantity, that is equal to scalar quantity, that is work done on the particle. Next, once work done is known, we can go back and find change in kinetic energy, delta Ke or delta T. Once kinetic energy is known, then power is equal to delta T by dt by T, dt by dt, or d by dt of kinetic energy. Now, I will just give a brief of units here, so that you will appreciate what are the units of delta S. Meter, that is length. Delta S by delta T, or ds by dt, or it can be written as for unit purpose only, velocity, that is equal to meter by second, and d square S by dt square, that is equal to dV by dt, that is equal to acceleration, meter per second square. Fourth, force, instead momentum we will take. P bar is equal to m into V, that is equal to kg into meter per second. Force is equal to dP by dt, that is equal to m into dV by dt, that is equal to m into A, that is equal to kg meter per second square. That is force. That is equal to, usually it is called in newtons. It is Newton. Sixth one, work done is equal to force into displacement. Force is Newton, displacement meter, Newton meter is equal to Joule. Sixth, kinetic energy, T is equal to kinetic energy is equal to half into mv square, that is equal to energy and work are scalars. Please remember that. Half into kg into meter square by second square, that is equal to kg meter square by second square is equal to joule. Kinetic energy is also in joules. Next, power P, rate of change of kinetic energy, that is equal to d by dt of kinetic energy is equal to joules by second, that is equal to watt. These are all SI units. SI units for different parameters of work, energy and power chapter. Now, we will be dealing in detail using the vector and also other than vectors. We will be solving the questions in work, energy and power in future classes. I think with this I want to conclude this lecture, and one more important thing I want you to know is velocity gradient. What is velocity gradient? What is gradient and rate of change? What is the difference between rate of change and gradient? Rate of change of parameter, of any parameter, is equal to d, change in parameter, that is dx by dt with respect to time. This is change in parameter with respect to time. There may be instances where we do not have change in parameter with respect to time. Then there will be gradient of parameter. What is that gradient of parameter? dx by ds, where s is the spatial distance, rather we can say, that is equal to change in parameter. This is very, very important, because as we are moving further in work, energy and power, these are also required. Change in parameter with respect to space. Space in the sense, in unidirectional it is dx. In 2-dimensional to 3-dimensional we can say dx dy and dz, or we can say ds. Velocity gradient means velocity gradient let us say unidirectional in Vx, velocity gradient in x direction, let us say, is equal to velocity gradient change in velocity in the x direction divided by change in x direction. In x direction. Similarly, if it is required in y direction, dvy by dy. This can also be dv by, in space it will be ds. Very important. dv by dt is equal to, acceleration is equal to dv by dt. That is equal to dv by ds into ds by dt. So that ds gets cancelled. That is equal to v into, dv by ds into, when vectors are there we should not change the direction, order. If you are given the velocity and velocity gradient, you can know the acceleration. That means from velocity and velocity gradient you can know the rate of change of velocity, positional vector and vector velocity vector. Once velocity vector and positional vector and rate of change of velocity vector with respect to the positional vector we know, then we will be able to know the acceleration of the particle. This is the importance of that positional vector and velocity vector. This is change in velocity vector with respect to positional vector. That means ultimately we have come back to our original understanding of the physics. With this, we understood many things: positional vector, rate of change of positional vector, velocity vector, and how to find the state of a particle. From state of a particle, how to find out the rate of changes, and how to define work, and how to define energy, and how to define power. And their units also we have understood. Now, from next class onwards, we will be going into the practical examples. I thought this is very essential to know the minimum theory behind understanding work, energy and power, a little bit of vectors. Please be ready, study some little bit of vectors and little bit of calculus, which I have explained in my previous lectures. Please see them and try to understand them, and in the next class we will be taking up advanced topics and solving some certain problems in work, energy and power. Best of luck to you. Thank you for seeing my lecture. Thank you for listening to me. If there is a value addition because of this lecture to you, kindly hype this lecture, hype this video, kindly share this video and subscribe to my channel Maths and Science by IITian. Best of luck to you all. Thank you. Please hype, share and subscribe, and you can join as a member to my channel also, so that you will be able to have early access to my videos. Thank you, and be a member of my channel and hype this lecture and share and subscribe. Thank you.